What's up everyone? This video is about retrieval augmented generation, that is RAG. I will explain you a sample RAG pipeline as well as a response refinement pipeline. However, before starting the video, let me tell you that this is a general pipeline and not a strict one. This is just to explain the working of a RAG application in brief to someone who is new to this technology. Now, coming to the topic, firstly, in case you are not aware with RAG, let me give you a brief explanation about it. RAG is a technique through which existing LLMs can be powered to generate a domain-specific response to the user's queries. For instance, currently LLMs are trained on publicly available data and they cannot answer accurately some of the domain-specific questions, for example, medical, engineering, legal, academic, etc. To generate response for these queries, LLMs require the most relevant and the updated data. RAG helps solve this purpose. This was a brief description about RAG. In this video, I have covered various divisions of RAG. Moving forward, I will explain RAG pipeline from a high-level view and then we'll go in a bit depth. This diagram gives a brief idea of how a RAG application works. Firstly, the domain-specific data is stored in chunks in vector database. Later on, when user tries to prompt a query, it is first sent to a vector database to get the relevant chunk of data from the domain-specific data which contains the answer to the user's query. Further, this relevant chunk of data and the user's query is passed into a prompt template. Prompt template lists all the instructions for the LLM to generate the response. It contains all the requirements to give LLM context of how the response is expected. Once this is done, the prompt template is further passed to the LLM to generate the response. The generated response is later sent to the user. This is an overall picture of how a RAG pipeline works. Now I will try to explain the same working, but in a bit more detail. Here it is. The first step in a RAG pipeline is the ingestion of domain-specific data into the vector database. This domain-specific data can be in any form, for example, PDF, Word file, audio file, video file, etc. Although the data from some files like audio file, video file needs to be pre-processed. Once the data is ready, it is splitted in various chunks. For instance, if the data has 3 paragraphs, it can be divided in 3 chunks. Further, using the embedding model, vector embeddings are created of these chunks. Vector embeddings allow machines to understand the relationship between different words based on their context and meaning. Then indexing is created for the generated vector embeddings. Indexing makes it efficient for vector database to search for the relevant chunks of data. Further, these embeddings and the splitted data in chunks are stored in a vector database. This ends the process of ingestion of data. Now the user can prompt LLM to get the knowledge-based response. When user passes a query, again using the embedding model, embeddings are generated for the query. Then these embeddings are passed to the vector database to get the relevant chunk of data which can answer the user's query. Since the chunks of data are stored in embeddings, it becomes easy to search for the relevant chunk of data through the embeddings of the user's query. Vector data returns all the data which has embeddings around the query embeddings of the user. I have explained this process with a practical example in my blog series. If this is confusing for you, I would recommend you to check them out to know more. Coming back to the topic, when the relevant chunk of data is there, along with the user's query, it is added in a prompt template. Further, this prompt template is passed to the LLM and the generated response is sent back to the user. I have kept all this process in vector database library LangChain because when you use frameworks like LangChain and vector database, all this process are taken care of. However, you still need to initiate the instance of a vector database and the embedding model and pass the embedding model to the vector database instance. But all these other operations are taken care of. Let me show you this particular step programmatically. In this project, I am using Gemini's embedding model and PG vector. In this function, firstly, I am initiating the embeddings model. Then I am initiating a PG vector by passing this embedding models instance, which was declared. Once I get the instance of this vector store, in the next step, I just need to pass the splitted chunk of data to the instance of this vector database and everything else, that is generation of embeddings and storing the data in a vector database, will be taken care of. This is a general pipeline that a RAG application can have. LLMs produce good but often imperfect results. No single model is perfect for all tasks. Users often don't want to spend time providing feedback. To solve such an issue, a response refinement pipeline can be incorporated. This can help to make sure that the response generated by the LLM is the most accurate to satisfy the user's query. Now, I will walk you through a response refinement pipeline. Again, there is no hard rule for such a pipeline, but this is one of the way it can work. This is how a response refinement pipeline can look like. I will directly start from the generated response by LLM1. All the other operations are the same as explained before. Now, the generated response which is received from LLM1 can be added to a prompt template for LLM2 along with the user's query and the relevant chunk of data. This prompt template will have requirements as follows: sending the user's query, relevant chunk of data, and the response generated by the LLM1 to LLM2, and asking it to score the generated response on a scale of 1 to 10 based on how satisfactory was the response. If the score is below 7, asking LLM2 for suggestions to improve the response. Further, this prompt template will be sent to LLM2, which will return the score as well as the suggestions to refine the response. In the next step, the suggestion, user query, and the relevant chunk of data is added to a prompt template for the LLM3. This prompt template will have requirements as follows: sending the user's query, relevant chunk of data, and the suggestions by LLM2 to LLM3 and asking it to generate the response to satisfy the query based on the relevant chunk of data while keeping all the suggestions by LLM2 in mind. Finally, the generated response by LLM3 will be the refined one, and this will be sent back to the user. This was the response refinement pipeline, and again, it can be modified as per the requirements. Further, discussing the disadvantages of such a pipeline which has the multiple LLMs involved. The very first one is the cost involved in using multiple LLMs. Secondly, due to more number of stages, it can delay the response time. Additionally, due to this pipeline, the response may get overly polished, reducing the user engagement. Alright, that's a wrap. Thank you so much for watching this video. Let me know if you have any questions or suggestions.